In this section, you're going to be studying real-world events that are occurring over time. As time passes, things change. And so it is possible to observe an event occurring and notice that there are multiple variables that are changing at different speeds, or in other words, rates, all at the same time. And that the change of each of these variables is interdependent because they're all working together to create this event. And this is why we call it related rates. This section is the perfect example of why calculus was created, because we needed a math that could actually calculate what we needed to know about our lives. And life is always changing. And that's why we have calculus. So, let's consider a drone that's hovering over a swimming pool. As the drone approaches the water, the wind from the fans of the drone beat the wind, and it causes concentric circles to expand within the water. So as these circles are each expanding, within each circle there are 3 variables that are changing all at the same time. So take a look and pause for a second and write down, what 3 variables do you think are changing at this moment in any one of these concentric circles? So the first thing that's changing is the area of the circle. Now, area is a formula, pi r squared. It has a variable within it. Therefore, when I do my derivative notation, because I'm deriving the change of the area, then I am using a capital letter to notate that that A has variables within it. So delta could be the D, or it could be the triangular symbol of the Greek letter. And so delta A over delta T, change in area over change in time. The second thing that's occurring is circumference. Circumference, also a formula, so change in circumference over change in time. Also, the C gets a capital letter. The third item, radius. So radius is a linear measure, not a formula, and therefore is all lowercase. dr over dt, change in radius over change in time. Now some of you might have said, oh, the diameter is changing, and you're right, the diameter is changing, but the radius is half of the diameter, and therefore, relatively, even though radius is not equal to diameter, dr over dt is equal to dd over dt. Okay, these problems in this section can get quite challenging, so I have a list for you to follow to help keep you organized and to make you more efficient as you're solving these problems. So I'm going to read through them real quickly, but then as I do the problem, I'll be demonstrating and tell you what step I'm on. So you're going to look at the problem that you're given, and even in real life, you would want to draw a picture and be able to visualize. If you can visualize something, you can think it through. Secondly, you want to be able to assign meaningful variables. So for example, if you're talking about height, well then let the variable be h, because that makes sense. And then somebody reading your work would be more likely to understand what you're doing, as well as you going back and rereading your work. Step 3. Organize your information in a find when given list. I'm going to show you exactly how to do this because I expect to see it on a test. Now, this is specifically for me because I'm trying to instill in you a very organized way of doing your work. So I'm going to give you points for your find, for your when, and your given. Okay, your find and your given are always rates of change, and your when is always a value of a variable at a specific moment in time. Step 4. Everything that you've learned in math up to this point, from the time that you learned the Pythagorean theorem until now, so you've been through algebra, geometry, algebra 2, pre-calculus, and now in calculus, any formula you have ever learned could be used depending on the relationship you're looking at. For example, if your problem shows up in the shape of a triangle, well, you know your Pythagorean theorem, you know area of a triangle, and you know trigonometry. So you have 3 options to choose from. So you would want to look at your relationship, look at your information, and see which one applies. Okay, step 5. Once you're happy with the equation that you've chosen, you want to compare and make sure that your variables match what's in your find when given list, because you don't want variables to show up in your equation that you don't have any information about. And so I'm going to do a problem that has this issue, and I'm going to show you how to fix it. Number 6, once you have your matching equation to your find when given list, you're ready to derive. So you have all your derivative rules, be careful, remember them, and derive correctly. Number 7, when you have your derivative done, you want to make sure that you've expressed it in what you've been asked for. For example, if I derive area, then I get dA over dt equals this variable expression. But if I was asked to find dr over dt, well, it's embedded in the expression. I don't want that. I want it to say dr over dt equals, if that's what I was asked to find. So make sure that you solve for it and give a variable expression. It's part of your answer, and you even get a point for that from me and on the AP test. Okay, 8 and 9. Once we've gotten to the end of the problem and we've derived it, now is the time to plug in the information from our find when given list. We don't want to do this earlier, because if I put in numeric values and then I derive it, well, a number just derives to 0 and I end up with nothing. So remember, you want to be able to derive variables. So leave everything in variable form until the very end, and then plug in what you know and simplify it. So number 8 should be a nice simplified fraction, no decimals whatsoever. Number 9 should then be put in a calculator and give me a 3-digit decimal. That means the decimal point and 3 digits after it. So don't forget to write your units of measure. If you're talking in meters per second, then make sure you write that, because it's worth points. Let's do a problem. Okay, so let's read it. Water is pouring into a conical tank at a rate of 2 liters per second. The tank is 10 meters high and has a 6-meter diameter on top. So I have a conical tank. Water is pouring in. What's changing? Volume. So that means change in volume, 2 liters per second. I'm doing steps 1 and 2 all together. Okay, my tank, H equals 10 meters, and my diameter, D equals 6 meters. Okay, then they asked me the question. Find the rate at which the height of the water in the tank is increasing. This is where I start my find when given list, step 3. So find when given. So find the rate of the water, of the height of the water. So change in height over change in time is my goal. And they want to know when the water has reached 3 meters high. So my when, H equals 3 meters. My given, always a rate. What did they give me as a rate? dV over dt is equal to 2 liters per second. Okay, just a few pieces of information about what I was given. The fact that water is pouring in to the tank means the water is increasing, and therefore that's a positive event. So I was correct in putting positive 2 liters per second. I also know that because the water in the tank is increasing, my dH dt will also increase, And that's what they're asking me. How fast is it increasing? So my answer should also be positive. Now, if they had been draining water from the tank, then that would have been a negative rate of change of the volume and a negative answer because the water would be dropping. You guys understand how to read the problem and make sure that you're putting correct positives and negatives. Okay, so I have the problem drawn. I have it labeled. I have my find when given. I'm ready for a formula. So this problem's all about volume, and the volume of a cone is 1/3 pi r squared times the height. Okay, and so now I'm ready for step 5, where I check and make sure that all my variables are okay. So in my head, I'm deriving and looking to make sure my notation is going to be okay. So if I derive v, I'm going to get 1 dv over dt. And I look at that and I say, well, that's in my given, in my find when given list, so the v is okay. The 1/3 and the pi are both going to sit and wait for me. So they're okay, they check off. The r, notice I was never given an r, although I could find it because r is half of d. But the problem lies in the fact that if I have a variable r and a variable h, then this is the product rule. And that means not only will r stay in my formula, but a dr dt will show up, and that's a problem. And so this is something I'm going to have to fix. It's a problem. The h is actually what I'm given and what I'm asked to find. So I know when h is 3, I'm going to be doing finding the dh dt, and so that's a good variable to keep. It's the r I want to get rid of. So I'm looking for a relationship between r and h, and I remember from geometry that if water's pouring into a cone, that it's creating a similar cone in the base, so that the radius is similar in the water as it is in the tank, and the height is similar in the water as it is in the tank. And so if r is half of my diameter, then I know that using the ratio of my tank, my radius relates to my height in the proportion of the measurements of the tank. The radius was 3, the height was 10, and therefore r is equal to 3 tenths h, using my properties of similarity. I can take this value now, and I can plug it in, and I no longer have a problem. So, rewriting the equation, v equals 1/3 pi 3 tenths h squared, because r was squared, times h. Simplifying a little bit, 3 tenths squared is 9 over 100. H squared times h is h cubed. Now I'm ready to derive. Notice I didn't simplify fully because I know using my power rule, my 3, when it drops, is going to get rid of that 1/3. So sometimes simplifying fully, if you're not thinking about what you're going to be doing in the next step, makes more work for you. So now I'm going to derive 1 dv over dt. I notate every variable I touch. The 3 drops, the 1/3 cancels, and I get 9 pi over 100 h squared. I derived the h, therefore it gets a notation, dh over dt, and that's my derivative. But it's not what I was asked to find. And so I want it to match, so I'm going to take this fraction and I'm going to reciprocate it to the other side so that I can give my answer in the form of dh dt equals 100 over 9 pi times h squared. And it's multiplying dv over dt. Okay, so that's one answer. That's 7. Step 8 says I can now plug in. So dH over dt. H is 3, so I'm squaring it. And dV over dt is 2. Notice I didn't put any units in. You can put your units in and they'll cancel and make a good equation for you, but I find that it gets really messy. For me, it's easier to logically think H is a linear measure. I'm measuring in meters. My time is in seconds. I'm measuring in meters per second. So when I simplify this, and I get 200 over 81 pi, I put it in meters per second. And that's going to be approximately, when I put it in my calculator, I get 0.7957, and it's much longer than that, but I looked at 4 digits because I want you to round correctly, and so I have 0.796, and again, meters per second. And so I have one answer here, and I have one answer here. Okay, so just to summarize, remember, follow your steps, keep your work organized, make sure to pay attention on how the problem is given, and when you visualize it, try to think, are things increasing and getting bigger, going up? Those are positive events. Are things decreasing, getting smaller, going down? Those are negative events, so that you get your signs right, because one negative could throw off your entire answer. So be careful, but I think you're going to find these very challenging and interesting problems to do. So this one's for you. What I'd like you to do is give me an answer, but also come into class and show me your work so that I can see that you set everything up and you showed everything that you need to show. And then I can also find out if you have any questions. If you work diligently, you can get this homework done in 3 to 4 days. Now, I'm just going to give you a little advice. The internet is a positive and a negative. It has a lot of power. We can use it for resources, but we can also use it to simply just get answers from. These problems are challenging. You need to think through them. You're going to get stuck. If you get stuck, please come to me and let me help you. If you go online and you find problems that are similar or even identical to the ones that I'm giving you, then and you just copy them, you're not going to learn, and it's not going to help you. So please come into tutoring. This is where calculus is starting to get a little more difficult. So do your best, and do your best to grow. Good luck.